Yes, good morning to one and all. Uh, Last class we have seen that DC transmission system, and into that we have seen that various DC power supply scheme and volume of conducting material required for the single phase two wire system with the midpoint earth and one conductor earth. Okay, and into that we have seen that comparison. Okay, it is found that the area cross section of single phase two phase sorry two wire DC system with one conductor earth. Okay, and am I audible? Yes.
Yes, sir.
Yes, sir.
Okay, so last class we have seen that two wire DC system with one conductor earth and two wire DC system with midpoint earth. Okay, we have found that the area cross section of two wire DC system with the one conductor earth and two wire DC system with midpoint earth. Okay, so if we compare these two areas, it is found that the area cross section of two wire DC system with the one conductor earth is greater than that of the two wire DC system with the midpoint earth. Okay, generally it is uh, more than that of the second case. Okay, so volume of conductor required is also greater than that of the second case. So today we will see the next type of DC supply system. Okay, that is what three wire DC system. Okay, so see in the diagram, here is the two wires. I'm sliding my arrow pointer. This one is the one wire, this one is the another wire. Their common point or the junction point is grounded. From the common point, one more another conductor or wire is taken. That is what it is treated as third wire. Okay, means what? Neutral wire which is earthed at the generator end and which is taken outside for the connection. Okay, so these are the three wires. Okay, so three wire DC system scheme, we have to remember the diagram. Okay, so we have to see in this case also volume of conducting material required and area cross section of that one. Okay, and finally we will compare it two wire DC system with one conductor arch and the two wire DC system with midpoint arch. Okay, so in next slide we will see the area cross section how it will be found. Okay, so see over here the load current as our conventional method we have to find the load current first of all. Okay, so we will found that I3 which is a load current. Okay, I3 is equal to what? The phase voltage divided by the resistance of the line conductors. Okay, or the wires. So resistance is R3 over here. We have to remember this point. Okay, so see over here, if we found the load current, we have to find the total voltage or the potential difference between these 2 points. Okay, then and then only we can able to find the load current. Okay, so the potential difference across the load terminal is equal to what? 2 into Vm. Okay, Vm is nothing but the maximum voltage across the load terminal. Okay, so see over here, the maximum voltage DC voltage across the load terminal is 2 Vm. Okay, and consider a power which is to be transmitted to the load. Uh, which is denoted by the capital P. Okay, so the load current I3 is equal to what? P by 2 into Vm. Okay, so this is a required expression for the load current. Okay, let A3, this one is the third case, so that's why the area of conductor or the cross sectional area of the outer wire, okay, of each wire, it should have A3 area cross section. Okay, so line loss is equal to what? Here 2 into I3 square into R3. Okay, 2 into I3 square into R3. Okay, I3 value P by 2 into Vm raised to 2 into R3. Okay, so the R3 nothing but the resistance of wire. Okay, so resistance of the wire is nothing but what? Rho L by 3. Okay, so simply put these values. Okay, we will get the 2 into P square by 4 into Vm square. Okay, so finally we will get the P square rho L divided by 2 into Vm V to the suffix small m raised to 2. Okay, into A3. Okay, from this equation we will found that area cross section is equal to what? A3 is equal to P square rho L by 2 into W into Vm square. Okay, so W here is line loss. Okay, so remember that same procedure we have to follow for every supply scheme. Okay, in order to get the volume of conductor. Okay, so see over here, assuming that the area cross section of the neutral wire to be half that of the outer wire. Okay, and volume of conducting material required, which is equal to what? 2.5 A3 into L. Okay, so the volume of conductor required 2.5 into A3 into L. Okay, so remember this formula, 2.5 A3 into L. A3 is nothing but what? Area cross section of the uh, conductor. Okay, L is nothing but what? Length of the conductor. Okay, so we will get the final equation, 2.5 divided by 2 into P square rho L square divided by W into Vm square. Okay, so 2.5 can be converted into 2.5 divided by 2. It is further simplified as, see over here, 5 by 16 into K. Okay, so value of the K over here 4 into P square into rho L square divided by W into Vm square. Okay, so see over here the comparison between the um, conducting material required in case of two wire DC system with one conductor earthed and three wire DC system. Okay, in case of the uh, two wire DC system with one conductor earthed, the volume of conducting material required, which is treated as K. Okay, so volume of conducting material required in case of three wire DC system is 16 by, sorry, 5 by 16 times of volume of conducting material required in case of two wire DC system with one conductor arched. Okay, first case मध्ये बघा, volume of conducting material required, which is equal to what? K. Value for the K is what? 4P square, a rho L square divided by W into Vm square. Okay. So in case of this three wire DC system, the volume of conducting material required, which is equal to what? 5 by 16 into K.